Hey everybody, and welcome to our first design video for our Mechanical Engineering Senior Project. This is a project that we must complete before we graduate from Oregon State University. My name is Peter Oliver.
My name is Sam Heck.
My name is Ryan Jones.
We are here today to tell you a little bit about our senior project and what you can expect to see over the next 4 months.
But first, we're going to tell you a little bit about ourselves.
I grew up right here in Tualatin, Oregon. I love to play basketball and I love to fish. Ever since I was young, I've enjoyed building things. In high school, I joined a robotics team where I got to build a robot that plays soccer. It was such a great time, and ever since then, I've wanted to be an engineer.
I am originally from Bozeman, Montana. I grew up playing ice hockey my whole life, and I love to hike and camp. I grew up on a farm and was always helping my dad with the farm equipment. When it came time to go to college, I knew that engineering was right for me.
I grew up in Fairview, Oregon, just east of Portland. In high school, I ran track and cross country. I was an active member of the robotics club, and we built a robot that was designed to travel on the moon. Engineering was an easy choice for me, and I haven't looked back since. Now that we all know each other, let's take a look at what we're building.
We are designing a system that will show you how electricity is generated and how much electricity is used for certain operations.
More specifically, we're going to have you generate power, and we'll show you a few cool things you can do with it.
Before we dive in, we need to take a step back though. The most important thing to remember when engineering something is who you're engineering it for.
We call this person the customer, and it's important to know what they want. Since you are all our customers, it is important we know what you want and we design something that you want to use.
The first step in our process is to create customer requirements. This will be a list of specific requirements that we need to meet for our customer.
Here are a few of the requirements that we thought were the most important. Durable. We want everyone to really be able to work hard to generate as much power as possible. This means the system can't be fragile and must be able to withstand a lot of force.
Safe. Nobody wants to try something if they are worried about being shocked or hurt. It is very important that our design has no exposed wires or sharp edges.
Engaging. We want all of you to have fun. Of course, there's an educational purpose, and it is important that you learn something, but we are going to create something that you want to use.
Here you can see the final list totaling almost 20 different requirements.
Now what do we do with these requirements? How do we assure that they're all met?
Well, Sam, that actually leads us to the next step. We create something that is called a house of quality. This allows us to relate requirements to each other and decide which ones are the most important.
Here we can see part of the house of quality for this project. You can see that some requirements are more important than others, allowing us to focus on them more specifically. It also relates them to our engineering requirements.
Engineering requirements.
These are requirements that can actually be measured. For example, if durable is a customer requirement, the engineering requirement might be that it can withstand 50 pounds of force.
Here you can see the full house of quality for this project. It has additional information, and with all those extra requirements, it becomes much bigger.
So the house of quality is pretty much a tool that allows us to turn our customer requirements into measurable and achievable goals that we can actually reach.
Exactly, Sam.
Now that we know who we are designing for and what they want, the next step is to start modeling and coming up with ideas.
The first part of modeling is to draw preliminary sketches. These allow us to get our ideas on paper and discuss them as a group. We are then able to choose the best design for our customers.
The system we chose is modular. Modular means the device is divided into smaller systems.
Here you can see all three modules, 1, 2, and 3.
You will use a hand crank to generate electricity and power. The harder you turn the crank, the more power is produced. You will use the hand crank to generate power for one of two things.
The first station is a water wheel. You will power a pump that will move water from a lower reservoir to an upper reservoir. Once the upper reservoir is full, you will be able to turn a valve and release the water onto a water wheel.
This wheel will spin and generate electricity just like at real dams. We will be able to see how much power both you and the wheel are generating by looking at various displays. The second station will be a video game. As you crank and generate power, a TV will turn on, allowing you to play one of a few simple games.
You all will then have to work as a team to play the game, as each player will only be able to control either up, down, left, right, or fire.
With both of these modules, it is important to continue cranking or they will turn off. With the preliminary sketches completed, it is time to start generating 3D models with accurate dimensions. To To do this, we will use a program called SolidWorks.
This program allows us to generate digital models of our components to be inspected, improved upon, and eventually fabricated.
Here you can see the 3 modules in SOLIDWORKS. Here's a completed model of the hand crank. Notice that the input method has changed from a crank to a wheel. This makes the device more durable and tougher to break.
Here is a solid model of the water wheel. Again, notice the additional detail added to this level of model, including legs to prevent the device from tipping over.
Here is the entertainment system. You can see that in place of the box that the buttons were on in the sketch, there are now individual wires that allow users to spread out more while using the device.
And if you put them all together with a little bit of motion,
This concludes the first of 3 design videos for our senior project.
in the next video we will discuss prototyping and production.
Thanks, and we'll see you next time.